And it's quiet now. Third of 150 is 50. So I will then have to indicate that from the center here to a third of 150, it will therefore be my 300 plus 50 and that gives me 350. That gives me 350. So the 350 is from where you can see my cursor now to the center point of my extra section, of my ream section. And that will mean that in order for me to determine the circumference, it will be the circumference from there to there. I know it might not make lots of sense, but it'll be the circumference that we will have not of the outside, but the circumference of 50 millimeter into my ream section. That's the circumference that I need to determine. So if I have the 300 plus the 50 millimeter of what I had now learned working from the base of my cross-sectional properties in structure, that this instance will be 150, a third of 150 plus the 300. I can then work with that and I say that it is then, the circumference is then 2 times pi times the new radius that I've now determined of 350, and that will then therefore give me, if you can calculate that, it should give you 2.1991. So that in essence gives me 2.2 meters of a circumference. I need questions now. Do we have questions? Or are we okay with what I've just said? Everybody good with what I've just said?
Could you please repeat it? I didn't hear you clearly.
You could not hear me clearly. Okay. Right. I'm saying that. Which section must I repeat?
I heard you up until where you got the 350. After that, I didn't hear anything.
Okay, Nomta, you said you heard me after I got this 350 here. Right.
Yes.
Okay, now that 350, I'll say again, take me from the center to 50 millimeter into my section, my ream section. Now I need to determine. Yes.
Can you please just move a bit below that, where you get this 51 first? I'm a bit lost.
Where I get the?
51.
No, that's not 51. That should be 50.
50. Yeah, can you please just elaborate there?
Okay. What I'm saying is, if we have a look at that, there is the reams, is this section here, and that's enlarged. Okay, and that there is 150. Right? And when we deal with known structures, if we need to determine the circumference of that section, because this goes all the way around, I will have to now work to a third of the base. And a third of 150 is 50. Third of 150 is 50. So it will be the 300, which is my normal radius, plus the 50, which is a third into this reamed section, and then I now need to determine the circumference of that you can see where you can see my cursor. Now I need to determine that circumference, because that will give me the center. And when I have a triangular shape, the triangular shape that tells me that I work a third for the center line of that. It's a third off my base, and that is a third off that, and that gives me the 350, and my my formula would then be 2 pi radius, and that radius is therefore the 350 millimeter that I have determined. And that then gives me 2.199, and because I work in 2 decimals only, that means it is 2.20. And that's going a long way in getting to that. And that will then give me what I need to determine. And if I look at the 2.2 multiplied by 0.15, and I have there multiplied by 0.26. Now, how on earth do I get to the 0.26? How do I get to the 0.26? I'm just going to clear up some stuff here again. I get to the 0.26. I know that this is 60 degrees. It's given to me there, 60 degrees. I know that this is 150. So if I work with the tan of 60, the tan of 60 equals, my tan of 60 gives me my opposite over my adjacent. So I'm just going to go and I'm going to do this, and I say that the tan of 60 equals my opposite over 150. Now, what does my opposite then determine? Well, what does it come to? If you will use that, you say 150 tan 60 equals the opposite, and that then gives me a length of 260 millimeters. Do you agree with that? Have you calculated that? So I take it the silence means that we are with me. So if you do that, it means that in order for me to calculate all of this all the way around, I will then use the 2.2 multiplied by 0.15 multiplied by my height, which is 260, multiplied by 14 times half, because my shape there is triangular. Okay, all good.
Sorted.
Okay. Now I want to show something else. I want to literally throw the cat among the pigeons and just try something else out, and let us see whether this would work if we do that. You all remember the prismoidal formula? You remember the prismoidal formula?
Yes.
That says h over 6 multiplied by the large area plus the small area plus 4 times the middle area. You remember that one?
Yes.
I think I still taught you that formula in first year, if memory serves me correct. Now,
We are talking not from the same institution, we from another institution.
it doesn't matter. You would have done the prismoidal formula in there too if you were at Walter Sisulu. You would have done that with Mr. Elliott. So yes, you would have done that the prismoidal formula, whereby especially used where we deal with bulk excavations. Can you remember that? Do you not remember that?
Yes.
Yeah. So. See, fortunately, I know because I am a moderator for Walter Sisulu University, so I know a little bit about that. Right. So when we look at this is what I want to do. We've now determined that height there is, how much is that height? 260, right? We know that the height from there to the bottom is 7 meter 800. And I want to say to you, I want to cut that off there. And I want to over here, instead of saying 0.3 by 0.3 by 7.9, I want to say over there, I want to say, I want to just write something here quickly. I want to say to you that I say 800 minus 260, and that gives me, what does that give me? 800 minus 260, that then gives me 7540 millimeters. And I will explain what I'm doing. I'm taking the length from there to there. And I say that that length is length there is then, I'll then say that L is therefore equal to 7540. Right. I'm saying that L is 7540. What shape am I leaving myself with here?
Cylinder.
Leaving myself here with a trapezoidal shape. And then I say to you that I would therefore then say my height divided by 6, and I would then large A plus small a. I use that formula. Do you still remember that formula?
Yes, sir.
Okay. So I say that instead of going through what I've just done to determine that and to determine all that, we can also use this. And then instead of, when I then come to this here, I then say over here that I then say 0.3 0.3 7.54, and all of that. Remember, guys, I'm not just doing. That will then be 14 times pi. And I would then here. I'm just trying something else here. Okay. That now is my one. I've now deducted that. And then I can go in and I can then go and say here, over here, I now go and I say 0.45, 0.45, 0.26. All of that is multiplied by 14 multiplied 1/6. Remember, this here is 1/6. It's not 1 times 6. It's 1/6. And I have that there. That's my large area. And then can continue by saying 0.3, 0.3, 0.26, it'll be 14 times 1 over 6 times that. That's for my top area. Because I'm going with my formula that I had inserted over here of h over 6 multiply large A plus small a plus 4 times my middle area. Now go back to this. The next one here would then be the average of that, which would then be 300 plus 450 and all of that
375.
divided by 2, that gives me,
375.
what does that give me?
375.
Because I'm not using, or I could say 600 plus 900 gives me 15 divided by 2 gives me 750, and the average of 750 divided by 2 gives me 375 millimeters. The 375 millimeters. So then here, I can then say down here, 0.38, 0.38, 0.38, 0.26, and I would have here I would have 14 times 4. This is now divided by 6 again, guys. That is very important. Times, if I can just highlight this. So that, now this will be 4 divided by 6, your formula. And if you then go and you square all of this, you should effectively get the volume over there. I'm not sure whether you have done that squaring there, and whether you've received that. Just as a test, you can do that, but just to show that instead of working with all of this here, all of that there, that you can, by creating a trapezoidal shape there and having your cylinder at the top, you can, and it's something that you guys, I would suppose, are a bit more familiar with. I'm not sure. You guys need to tell me, do you prefer the first method, or would you be okay working with this method that I have just shown over here? Now possibly is a good time to speak about that, to determine which one would work for you.
First method, sir.
You prefer the first method? No, that's great.
Yes.
You work with whichever one would be good for you. If you were good in using the trapezoidal formula, then this one should it should work for you. Yeah, it should work for you. I'm just going to do a quick calculation to see whether this would actually work. Right? I get 30.37 cubic meters if I do it with the trapezoidal shape. And if I do the other one, I get 31.47 cubic meters. Now that is a difference of, actually when I calculated yesterday, I got 31.39 cubic meters. I might have had happy fingers or fat fingers here. But whichever one you use, you would not be incorrect, because all you're doing is remember, you're turning this into standard shapes. And these are some of the standard shapes that we have used when we measured in our first year. All of us, no matter where we were, whether we were on a BSc in construction economics, or whether we were at a national diploma in building at TUT or Walter Sisulu or Nelson Mandela or CPUT, whichever, because that is the basics on which we would be working from. And I just thought that I would show that just to indicate to you that there is a different way in which you can go about and doing that. Okay. So next now, I now need to measure my 12 millimeter diameter mild steel reinforcement in my piles. And when I look at the steel reinforcement tells us in the standard system, it actually tells us in the standard system under piling, it says that the steel reinforcement shall be given in accordance with the principles laid down in concrete formwork and reinforcement. So I'll just go to there. It tells me that a steel reinforcement shall be given to us in accordance with the principles laid down in concrete formwork and reinforcement. So when we go to concrete formwork and reinforcement, and we look at the reinforcement, says on page 30, reinforcement, it says that under general, reinforcement shall be classified according to the quality. Then it tells us further on, bending, hooked ends, and binding wire, cover blocks, and spaces in accordance with the relevant SABS codes of practice and maintaining the position during concreting. And that means it shall be deemed to be included in my description. That no separation of reinforcement shall be made for different concrete components. Indented or any other deformed reinforcement shall be given separately. Curved reinforcement shall be given separately. Helical reinforcement shall be given separately. Reinforcement in sliding or climbing formwork shall be given separately. Reinforcement to galvanized or otherwise treated shall be given separately. Reinforcement shall be measured to the design lengths. Calculation of masses shall be based on the values shown in the relevant structural steel tables issued by the South African Institute of Steel Construction. And no allowance in the mass shall be made for rolling margin. So what this means is that we will be measuring this steel reinforcement separately. So the steel reinforcement will be measured in tons. It will be measured in tons. And now what do we do? So it says different diameters shall be given separately. Bars in lengths exceeding 13 meters and not exceeding 18 meters shall be given separately, thereafter in stages of 1 meter. So what does that mean? It means that we would start out by saying, measuring our steel reinforcement up to 13 meters, not exceeding 13 meters, and thereafter we'll say exceeding 13, not exceeding 18, and thereafter exceeding 18, not exceeding 19. That is our increments of 1 meter after 18 meters. So when I measure my reinforcement, I was told that the diameter of my reinforcement is 12. It's 12 millimeter diameter. The spiral is 10 millimeter. I've been told that the length is 7 meter 800. So I will therefore go through and I'll say 12 millimeter diameter valve steel reinforcement in piles not exceeding 13 meters long, because I was told that it is 7.8 meters. The drawing tells me that, and because it is measured in tons, I will write down my length thereof. There's 8 in each pile, and I have 14 piles. Whatever that value is over here would then be multiplied by the weight per meter, and the tonnage would then therefore be transferred to my bills of quantities or my abstract form, which I would use first. So I have 12 millimeter diameter, mild steel, not exceeding 13 meters long. I have 7.8 meters as per my legend, and I have 8 per pile, and I have 14 piles. My next one deals with the 10 millimeter diameter mild steel spiral or helical reinforcement in piles. Now I'm going to go to my standard system. It says that curved reinforcement and helical reinforcement shall be given separately. And I know that this is spiral, and we've done a spiral in our first year. We've done a spiral in our first year, and in the spiral we indicated that when we measure a spiral, that we now need to determine the length of the spiral, and the formula for the length of a spiral, it says that, I'll write that down here. It says that L, which is the length, is equal to and now I need to find the square root. Where do I find the square root sign? How do I indicate the square root sign? Oh, I cannot see where to find the square root sign on. Where are the fundis of working with PDF? If this was in Excel, I'd be able to do that. Anyway, I have the square root. I'm just going to put this there. The square root of what? Of c squared. I can't do this here, man. I need e squared plus p squared in all of that is multiplied by the number of p's. You remember that? You remember that? Can't remember. The number of p's. So, what do we use this? How do we use that? We need to determine L. And now we are given that L is that, we are given L as 65.8 to 86, but how do I get to that? When I substitute this here, C equals the diameter or the circumference, and that will therefore be pi times the circumference. My circumference is 600 minus 2 times 60. What is 60? Can anybody tell me what they think 60 is? When I say that C equals pi times my diameter. Oh, they're not pix. Let me rather do that. C equals pi times my diameter. And what is my diameter? My diameter is equal to 600 minus 2 times 60. What is that 60? It's the cover. Do you understand? You know what the cover is? That then gives me 480 millimeters. Now what does that mean? It means that the diameter for my steel, even though my diameter is 600, my steel cannot be placed at the 600 diameter. Does it make sense? Why can it not be placed there? It cannot be placed there because once that steel is exposed to the moisture in the ground, what will happen to that steel?
Rust.
It will rust. So what does that mean? It means that we need to have cover in the form of spaces that we would have on there, and we'd work with in this instance, we would work with 60 millimeter cover, and you'd be told what the cover is that you need to have. So my diameter for my spiral would in this instance therefore then be 480 millimeters. Does that make sense?
Yes. It does.
Does that make sense?
Yes.
Nobody talking to me.
It does.
No hands. No questions. So I take it we are all on board. Take it we are all here. We are all happy with what it is that I'm saying. That's it. Okay, right, fine. So I have my cover and I have taken my cover off. So my diameter now is 480 millimeter. So I can calculate this here by saying pi times my diameter. So I can say that my 480 and C would therefore be C would therefore be, and I'd need to have, it'll be C squared, so it'll be pi times my diameter and the square of that. Can you see that? I need a pen to write on this so I can show this to you. So if that is 480, it means that over here, the square root where C squared, it will be 0.48 multiplied by pi. So it will be, let me put this here. So that will be 0.48 multiplied by pi
Squared.
and the square root of that. That will be C. Okay, happy with that? So that goes in there. And then I have plus, what is P? What we were given P as 180 millimeter. There. It was given to us over there as 180 millimeter. So I go back and I say that plus 0.18, 0.18
Plus number
And I'm going to do,
times number of peas.
because I don't have and the square root of that, and the square of that. And of course, we need to find, I do not want to add a dot, or a circle, I need to write. So we'll have to have the square root of that, and then that multiplied by
Number of peas.
multiplied by, and what are the number of peas? How many peas do we have? I will then therefore have to say 7.80 divide 0.18. Because that will give me the number of peas that I would then, and therefore, where is my highlighter now when I need it? Guys, where can I find so the square, and then if I do this here, it's not that either. So the square root, and I'm just going to highlight that. You need to calculate that, and the square root of that, and that multiplies by the number of p's, and that should give you my 65.86. Do you get that if you work with me on the calculator? Silence. Silence.
So is it okay if I get 65.81?
That's fine. If you did you work through everything like that? That is fine. We will work with that. I will work with what you have and what you can show me.
Okay, thank you.
Okay. Yeah, I get 65.81. I've just calculated it now. I get 65.81. That is fine. Right? And we have 14 of those. And that is to determine the length of my spiral. But it also is important that we do not forget to indicate that all of this is
Tons.
that all of this will be measured in tons. As per the standard system, that tells us that the steel will still be measured in tons. Over there, it tells me that my steel will be measured in tons. Okay. So as we make our way forward, and we now look at the pile caps. The pile cap, as I said, is a square. In this instance, it's a square object. It is. It'll only have one pile placed under it. It's a square object, and we will have our pile cap. We'll have to excavate for the pile caps, and I'll go back to my drawing. We'll have to excavate for the pile cap, and in excavating for the pile cap, I will only be excavating there